Hello, my dear children. Welcome back to my channel. Today, we are going to discuss about Grade 10 Chemistry Chapter 1, in that the different types of chemical reactions. As we know, in this chapter, it mainly discusses about chemical equations and reactions. We are moving to the different types of chemical reactions. Okay? There are different types of chemical reactions: combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reaction, which is also known as redox reactions. Let us learn this one by one. First reaction is combination reaction. As the name indicates, it is the combination of different substances. It is the combination of different substances to form a single product. I'll give you an example. Normally, painters uses quicklime, and you might have seen they use a stick to stir it. Why can't they use their hands to stir that? Actually, when quicklime dissolves in water, it releases heat energy. When quicklime dissolves in water, it releases heat energy, and this heat energy, it's not safe to the painters to use their bare hands. That's the reason why they use a stick to stir it. So, quicklime dissolves in water to form calcium hydroxide, that is slaked lime. This quicklime is chemically calcium oxide. Calcium oxide dissolves in water to form calcium hydroxide. In this example, you can see calcium oxide dissolved in water. Two reactants combine together to form a single product. You can see the product calcium hydroxide as a single product. It is the result of the combination of two different substances. And I have used the term reactants. What is a reactant or what are reactants? Reactants are the substances which combines together to form the product. Okay, so in this case you can see when two or more reactants combine together to form a single product, it is known as combination reactions. And even you can use any other examples, not only this one, any other examples. Like hydrogen and oxygen combine together to form water. In all these cases, you can notice that the product is a single product. That's about the topic combination reaction. Next one is decomposition reaction. What is decomposition reaction? Normally, this decomposition reaction is known as opposite of combination reaction. Now, I hope all of you understood what is combination reaction. It is the combination of different substances, right, to give a single product. But in decomposition reaction, a single reactant decomposes to form two or three simpler products. A single reactant decomposes to form two or more simpler products. And here the process happens by absorbing heat energy. See children, in the first case we have learned, in the case of combination reaction we have learned, it releases heat energy. And in this case, it absorbs the heat energy. I'll give you some examples, then it will be easy for you. See, ferrous sulfate crystals. These ferrous sulfate crystals are actually pale green in color. These ferrous sulfate crystals, when we heat it, this decomposes to form two or three simpler products, such as ferric oxide, sulfur dioxide, and sulfur trioxide. In that, you can see the equation also. A single reactant, ferrous sulfate, decomposed by giving three different simple products, right? Another examples are lead nitrate. When it absorbs heat energy, it decomposes to form lead oxide, nitrogen dioxide, and oxygen. In this case, one more thing, we can easily identify the presence of nitrogen dioxide by the emission of a brown color fumes. In the test tube, once this substance have been heated, the production of different substances we can notice. And even another example like calcium carbonate. Calcium carbonate decomposes to form calcium oxide and carbon dioxide. These are certain examples for decomposition reaction. See, I already told you decomposition reactions. In this, heat energy is absorbed, right? But in case of combination reaction, heat energy is released. In a chemical reaction, when heat energy is released, it is known as exothermic chemical reaction. It is known as exothermic chemical reactions. Whereas in a chemical reaction, if heat energy is absorbed, that is known as endothermic chemical reactions. So in the first case, you can see heat energy is released, whereas in the second case, heat energy is absorbed. So this reaction, decomposition reaction, is also known as thermal decomposition. Let us see the different ways by heat energy is absorbed. First one, by sunlight. Silver chloride, which is white in color, when it is exposed to sunlight, it decomposes to form silver and chlorine. Silver chloride, which is white in color, when it is exposed to sunlight, their sunlight act as the heat energy. So heat is absorbed from the sun and that particular compound decomposes to form silver and chlorine. The silver is grey in color, so the white color substance turned to grey. And even we can use silver bromide. Silver bromide also, in presence of sunlight, it decomposes as silver and bromine. See children, this reaction is also known as photochemical reaction of silver chloride because it was used in black and white photography. Even you might have heard that cameras which we previously used, there that film rolls may be there. That film rolls we cannot expose in sunlight because we used to say that the color may fade away, the photos we won't get. But the reason is that the silver chloride chemical is used in that. This silver chloride decomposes to form silver and chlorine. So the white color turns to grey. So it completely avoid this screen. What all things we have taken as a photo. Then next is electrolysis of water. Electrolysis of water, you can see it is the separation of hydrogen and oxygen from water. Electrolysis of water means separation of hydrogen and oxygen from water by using electricity. So in this case, you can see the setup here. We can use acidified water because already we know that acid only contact. So to acidify that, even we can use 1 or 2 drops of hydrochloric acid or sulfuric acid, and in this case water decomposes to form hydrogen and oxygen, and it is taken or collected in 2 different parts. Then next one is, already we have learned decomposition by direct heat. That is what we have discussed in case of ferrous sulfate crystals decomposes to form ferric oxide, sulfur dioxide and sulfur trioxide. Okay. Displacement reaction. Let me explain the concept with an example. Iron nail. The chemical formula of iron is Fe. So when an iron nail or blade dipped in copper sulfate solution, copper sulfate crystals are actually blue in color. When we dissolve this copper sulfate crystals in water, it forms blue color solution. Okay, so when we dip an iron nail in copper sulfate solution, the color of copper sulfate gradually fades away. So what's happening there actually? This iron is more reactive than copper. So it displaces copper from its solution. Iron being more reactive metal than copper, it is able to displace copper from the sulfate ion, and the color of the solution changes to pale green. The iron particles react with sulfate to form iron sulfate or ferrous sulfate, so that the color change indicate the formation of ferrous sulfate. That is what we can see, the pale green color. So in this case, you can see iron is more reactive than copper. In chapter 3, metals and non-metals, there you will learn the reactivity of metals. There you can see the reactivity. Iron comes on top of copper, indicating iron is more reactive than copper. So iron reacts and it displaces copper from its solution, and it is easy to remember, like in this case of questions like displacement reaction, you can see one may be an element, other one will be a compound. So the more reactive part, if the element is more reactive than the other metal, it easily displaces. This is just to understand when the equation comes. Okay, so displacement reaction, the more reactive metal displaces the least reactive one from its solution. Double displacement reaction. When sodium sulfate reacts with barium chloride, it gives us two different products such as barium sulfate and sodium chloride. Here actually, sodium sulfate and barium chloride both are white color powders. When we mix it with water, it becomes colorless. Okay, both are white in color, but when we mix it with water, it becomes colorless. When we mix this together, sodium sulfate reacts with barium chloride to form barium sulfate, which is a thick white colored precipitate, along with the production of sodium chloride. Here, this reaction is also known as precipitation reaction, because among the two products, one is a thick precipitate. So that this reaction is also known as precipitation reaction. In double displacement reaction, mutual exchange of ions take place. See children, sodium sulfate. Always remember, a substance when it loses electron becomes positively charged. Normally in case of metals, we learn metals are positively charged since they lose electron, whereas the substance which gain electrons becomes negatively charged. So sodium, as we know, it is a metal, sodium sulfate. In that, sodium is positively charged, sulfate is negatively charged. In the similar way, barium chloride. Barium is positively charged, chlorine is negatively charged. So mutual exchange of ions takes place. That means positive part combines with the negative part of the substances. So here barium reacts with sulfate to form barium sulfate. At the same time, you can say sodium reacts with chlorine. Mutual exchange of ions takes place in double displacement reaction. In displacement reaction, I told you it is easy to analyze or understand by using watching the equation, like one will be an element and other one will be a compound. In this case, both of them are compounds. Sodium sulfate, barium chloride. It forms a white color precipitate along with the production of sodium chloride. That white color precipitate is barium sulfate. This is about double displacement reaction. Next is oxidation reduction reaction or redox reactions. Oxidation. In oxidation reaction, a substance gains or receives oxygen. Okay, here for example, copper. Copper, when we heat this copper, it forms copper oxide. The brown color copper turns to black in color, forming copper oxide. In this case, you can see copper, when we heat it, it absorbs the heat energy and it gives the product copper oxide. Whereas in reduction reaction, it loses oxygen. I have given one example there which indicates both oxidation and reduction reaction. See, ZnO represents zinc oxide. Zinc oxide plus carbon. When this reacts each other, you can see zinc oxide. From that, oxygen is reduced. In the product side, you can see it's only zinc. Whereas carbon, what happens to carbon? It gained or received that oxygen to form carbon monoxide. So in this case, you can see both reduction and oxidation taken place. In a chemical reaction, when both oxidation and reduction reaction takes place, it is known as redox reaction. In this video, we have learned the different types of chemical reactions. If you feel this video is helpful, please subscribe my channel. Thank you.